Okay, special factoring techniques, section 10.R.2. We're going to start off this first part by talking about a particular type of trinomial that's called a perfect square trinomial. Okay, and what those look like are any trinomial that can be written in the form a squared plus or minus, could be a minus there, 2ab plus b squared. Okay, and that's not normally how you will see it written, but again, just if it fits in this form, then it can be factored. That's a plus b, okay, or maybe you can say a plus b squared. Okay, so that's one version of a perfect square trinomial. Another version would be a squared minus 2ab plus b squared. Okay, so that could be the perfect square trinomial. Any quadratic or expression that fits that form is considered a perfect square trinomial. In this case, this one would factor as a minus b, or again, you could say a minus b squared. Okay, so let's put this in the context of an actual problem so we can see what I'm talking about here. Okay, so our first example will be to factor x squared plus 10x plus 25. Okay, and so that looks like a normal quadratic that can be factored. Okay, but this is a special case, right? This is one of those perfect square trinomials because if you think about it, this is something squared plus something multiplied like this plus something squared. Okay, if I can put expressions or terms into these blanks here to represent the original trinomial, then what I have is a perfect square trinomial. Okay, so what do I have to put in there? Well, x, right? That would be x squared. 5 would give me, 5 squared would give me 25. Okay, and then what if I took these two and plugged them in here and here? Okay, if I multiply these three things together, I get 10x, right? So if I'm able to fill in those blanks exactly like I just did, then I have a perfect square trinomial. Okay, let's kind of talk about that a little bit more. What I'm saying is that if you take this one's square root, that's just x, and you think about that as that first term being squared, and then I take the last term, 25, and think about that as something squared, in this case 5 squared. And then I think about it as multiplying those two together, 5x times 2, and it gives me the middle term, 10x, then I have a perfect square trinomial. Okay, it's a lot to try to keep up with, but I promise it's actually pretty easy to spot once you try to, think about it like that. Okay, so anyway, what does this transform into? Well, that just means that this can be factored as x plus 5, right? X and 5. X plus 5 times x plus 5. Okay, or most of the time you'll just write x plus 5 squared. Okay, let's do another one. So we have x squared plus 6x plus 16. Okay, and the question is this a perfect square trinomial? If it is a perfect square trinomial, then I can rewrite this in a way that allows me to factor it quickly. Okay, so to think about that, I think about this x squared. Okay, that's x that's being squared. I think about this 16. That's 4 that is being squared. If I multiplied these two together, that would be 4x times 2 would be 8x. Okay, is 8x the middle term? No, it is not, right? So this is not a special factorization. This is not a perfect square trinomial. So in Hawks, you would select not a special factorization. Okay, ideally you'll do this enough to where in your head you can see it and figure it out from there. Okay, let's do another one, a little bit more complicated. Four xy squared minus 40xy plus 100x. All right, this one's meant to look scary. It's actually really not. Remember, the first thing that you should do when dealing with a trinomial or any sort of quadratic or expression is to look for a common factor. Okay, a common factor. In other words, a number that goes into all three terms that you can factor out. Okay, so I'm looking at the three terms. 4, 40, and 100, they're all divisible by 4. So I'll put that out in the front. X, 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 they all have an X. So I'll put that with the 4. And then I look at the Y's, but they don't all have a Y. And also, this one has a squared, and this one is understood 1, so there's no other common factor. So 4x is the common factor. Then the question becomes what goes in the blank. Okay, and there's a couple ways to think about this. One way is to say I'm going to divide each of these by 4x because that is, after all, what I'm factoring out. So that would cancel, and leave me with y squared. 40 divided by 4 is 10. The x's cancel, so that's negative 10y. And then 100 divided by 4 is 25. The x's cancel, so I'm left with plus 25. Okay, so I factored out the common factor. Again, the idea is that if I distribute this 4x back through, I get the original problem. Okay. All right, so now let's try to factor this, ignoring the 4x. Is it a perfect square trinomial? Okay, well, y, 5. If I multiply those together, I get 5y times 2 is 10y. Oh, look at that. That's what I have. Okay, great. So this is a perfect square trinomial. And so since I know it's a perfect square trinomial, I know that it will factor as y minus 5, y minus 5. Okay, and notice the minus sign. Again, that's just because of this one right here. Right? It fits that original description that we gave earlier, where it was minus and plus. Okay, that's something to watch out for. Those have to be a minus and a plus. Okay, and let me write this a little bit nicer. 4x, y minus 5 squared. Okay, so again, this was a minus, this was a plus, therefore these had to both be a minus sign. By the way, if this is not a plus, you do not have a perfect square trinomial. All right, example 4. 2x squared plus 8xy plus 8y squared. Okay, I'm going to look for a common factor first. 2, 8, 8, they're all divisible by 2. And they don't share common variables, right? You know, this one has an x squared, this one's an xy, this one's y squared, right? So there's no common variable I can factor out. So just 2. Okay, if I divide that, I'm left with x squared. If I divide that, I'm left with a 4 for y. Divide that, I'm left with a 4y squared. Okay, back to the world of perfect square trinomials. Focusing on this piece right here. Okay, so x squared. Okay, what's being squared there? That's an x. 4y squared. What's being squared there is a 2y. Okay, if I multiply those together, I get 2xy times 2, 4xy, right? Remember, a squared plus 2ab plus b squared, right? So you figure out square root of this one, you know, or what's being squared here, what's being squared there. You multiply them together, and then you multiply it by 2. Okay, that's why I keep saying times 2. Okay, so that's 4xy. Well, is that this? Well, it's not, but it should be, right? Think about that for a second. Apparently, I forgot to bring down an x, right? Isn't that an x and a y? Oops. I want to blame you for not correcting me, but it's kind of hard to do when this is pre-recorded, huh? Okay, so recap. This right here, 8 divided by 4, or 8 divided by 2 was 4xy. Okay, so that should have always been 4xy here. Okay, so that is what I get whenever I think about this in terms of perfect square trinomials. So therefore, it is a perfect square trinomial, which means that it can be factored. This is a plus, this is a plus. So it's going to be 2x plus 2y and x plus 2y, or just x plus 2y squared. Okay, let's do a similar one. Example 5, 9x squared plus 28xy plus 16y squared. Okay, I don't see a common factor. So now I'm going to check to see if it's a perfect square trinomial. Okay, so what's being squared? That would give me 9x squared. That's 3x. What's being squared? That would give me 16y squared. That would be 4y. Don't forget to multiply it times 2. And if I multiply that all together, 2 times 3 is 6, times 4 would be 24. 24xy. Okay, let's compare that to the middle one here. Oh, they're not the same, right? Not the same. So we'd have to say this is not a special factorization. Okay, let's do a couple more. Example 6, 4x squared minus 4x plus 9. Okay, well, what would give me 4x squared? That would be 2x squared, right? If I raise 2x to the second power, I'll get 4x squared. What would give me 9? Well, 3 squared. Don't forget to multiply it times 2. 2 times 2x is 4x, times 3 is 12x. Compare that to the middle term here. Not the same, right? They're not the same. So again, this is not a special factorization. Let's do one more. 25y squared plus 20x squared y plus 4x to the fourth power. Wow, okay. Well, I'm looking for a common factor. I don't see one from 25, 20, and 4, right? They're not all divisible by the same thing. Y squared, y, no y, okay, no common y. No x, x squared, x to the fourth, so no common x. So this one doesn't have any common factors. Okay, let's just kind of go through what we normally would do. Let's focus on 25y squared. 25y squared, what would have to be squared to give me 25y squared? That would be 5y. What would have to be squared to give me a 4x to the fourth? 2x to the second, right? 2x to the second squared would give me 4x to the fourth. And don't forget to multiply this times 2. Okay, 2 times 5 is 10, times 2 is 20. Y and x squared, they are the same, right? That center term is the same as that 20x squared y. So this is a perfect square trinomial, which means I'm just going to steal this and that to factor this out as 5y plus 2x squared. Again, 5y plus 2x times 5y plus 2x. Okay, so that would be perfect square trinomials.